I want you all to remember these two things about differentiation, right? So differentiate this here from a please. Olive, let me start now. Differentiate this here, please. What's the differential of 2x cubed? 6x squared plus 3, and that's 0, right? Yeah. Now, as I said, integration is the reverse, right? So if I were to integrate 6x squared plus 3, what am I supposed to get back? If I integrate this, I'm supposed to get back this, right? So how do I achieve that? By doing this example here. How do I achieve that, Vishish? Right? So you have to wait, you have to add and then divide, right? You didn't say that. So what would it be? 6x 2 plus 1 over 2 plus 1. Right? 2 plus 1 is 3. Right? And 3 into 6 is 2. Add 1 to the power, you get q. So you get back the original thing. Sorry. You okay with that? Now, what's the integral of 3? Well, remember this is 3 by itself. So it's understood, it is understood that we have x to the power. It's understood that we have x to the power 0 there. Right? Anything to the power 0 is 1, right? So now, what will the integral of 3x to the 0 be? 3x to the 0 plus 1 over 1. So we'll end up with what? 3 over 1 is 3x. All right? So in short, generally, how do we integrate a x to the power n? How do we integrate? We add 1 to the power and divide by the new power. Right, but we have a slight problem on it. You see the problem? What problem? We didn't get any constant. Right? But how we gonna get it? There is no way from this for us to get it. So what you do is right? Plus. Plus it tells us that a constant was probably there. Okay? Copy that down. I'll go there. How it is one. Why not more? Right, sorry. Right, so in general, you'll understand why it have plus C, right? So I'll show you there are times that you do have to use plus C. And the next most interesting thing about integration is that you can put it in calculation and get the value. No, they won't give you this, but they'll give you a value. I'll explain that in a little while. Right? One thing I didn't show you is why we integrate. Remember, I showed you why we differentiate. Right? Differentiation was designed to help find like gradients and then, right? At points where it curve. But if I give you a curve like this, right? Or a particular shape, sometimes there's one to know, okay, what is the area under the shape? There's one to know the area under the shape. And the way to get the area is that we have to integrate the function, right? Between two values. Let's call this value A and this value B. And I'll explain what that limits mean in the meantime. But in AdMath or in calculus, a very important application is being able to find the shaded area underneath here, right? It's an extremely useful concept. So in order to find that, we need to learn about integration. That's okay? Yeah. And also, the purpose of integration is to do the reverse, right? So if I give you the gradient function, you have to be able to give me back the original function. All right? So that's one of the uses, two of the uses here of integration. Right? And the next one, I'll give you all three one time. And a third application is one that you all might do in a project. For example, if I give you this bottle of water, and I said to find the volume of this, you can use integration. Right? Imagine this. Imagine I give you a line, right? and I rotate that line 360 degrees across the x-axis, what does it form? It forms like a cylinder, right? So integration now allows you to integration. If I rotate this 360 degrees, it will form a shape like that. And integration allows you to find the volume of that shape between limits again. I'll explain the formula later on, right? So there are three applications to get back the original, to find area, and to find volume. Okay? Those are three applications of integration. All right? It have one more in kinematic. No, it's not common. I just showing you for general knowledge. So you're showing a course. It's come every 5 years. When you write it. Since. No, skip it now. Right, this will come all the time, right? There's a whole question, right? This is number 5. Okay? Nice. So how do we integrate again? Add 1 to the power, divide by new power. How do I integrate ax plus c? Right? So try this here for me as an example. Integrate for me 6x squared minus 2x plus 4. How is it? Don't worry about that. And I'll see it close to that. So integrate 2x cubed minus 4x plus 3. Try number 1 quickly. Right, try number 1 quickly. Shucks, what is it? Oh, I'm doing this. Oh, I'll check that out. I will put the card in the photo. Yeah, 1 line, sorry. Copy down fast again. No, we did it already, but just going to work because stop bringing on the board. You can't do it. Or the volume formula Chelsea, right? Is pi by y squared minus 3 dx. Right? Pi between b and a of y squared dot dx. I have integrated part. Right, help Mautiana, Stefan, help Mautiana, please. Right, over 4 minus 4 squared over, right? And the integral trails 3. Don't forget the plus c, right? And you can make it look a little bit nicer. 1 over 2 x to the 4th minus 2x squared plus 3x plus c. Right? Now, how do we integrate things like this? What you would do, Javi? What you would do to integrate things like this? Huh? No, can't add to the power one thing as yet. You have to expand it out and then do it, right? I'll show you that. I'll show you that technique just now. Expand it out, expand it, and then differentiate. Then I'll show you our next method that you could use. Pi in front of it. Pi. Don't worry, I'll give you the proper thing now. There's no need. I'll just show you why I end up with power one. So now you get just learn the integral of 3 and 3, the integral of 5 is 5. Yeah, number 2 expanded brackets fast. For number 2 expanded bracket. Online, if any issues, let me know. Yes, that's on school Tuesday and Friday. Or you have Tuesday and Friday.
With no awards ceremony. Fridays.
Tuesday's awards ceremony. But the awards is for the whole school or just for Form 5?
It's
5 and 6 alone. And Form and Friday is up. Right, so when we integrate, when we expand this out, what we got? 4x squared minus, right, you gotta remember the shortcut to expand. The shortcut is 2x squared minus 1 squared, and then 2 by 2x by minus 1. Okay? 2x squared is this, minus 1 squared is this. How you get this value is multiply 2x by minus 1 and then multiply it by 2. Okay? Nice. And how do we integrate this? The integral, notice, once I start to add 1 to the power, I'm no longer writing this fancy symbol, right? So I'll end up with 4x cubed over 3 minus 4 over 2x squared plus x plus. That's okay? But it could also be done a different way. No? No.
okay.
You sure?
Yeah.
Because I'll bring any board for the next one.
Ah,
Very good. Right, so you expand, add 1 to the power, divide by the new power. Right? Sure you get that? 1 is for you. All right, so generally, here's what. Suppose the power here was like 5. What you'll do? Suppose the power here was like 5. Do you want to expand that 5 times? No. So there must be a shortcut, right? So the shortcut is this. To integrate something like this. Hello, watching? To integrate, you write back whatever in the bracket, right? Add 1 to the power, divide by the new power, and divide by the differential of brackets. See, he agreed, the big man agreed.
Yeah, nice.
Right? Right, differential of the bracket. So what's the differential of ax plus b? A. Right? Plus c. So that's the way we integrate. I mean, that's okay. You recognize that within the integration, we had to be able to differentiate. Okay? So you have to be able to differentiate. Right? I just have a feeling like current might go. So I go a little fast. I have a little feeling today is one of them. That's fair. Don't call us now.
So I'm gonna pull and see if I pull them. That's it. It's not like you know. Okay, but I guess something listen.
Try this here.
Different. So one episode.
How I get the x from the here? What's the integral of 2? No integral. What's the integral of 4? What's the integral of 1? Right? Hello? Everybody confused? All right, help me. What's the name again? Huh? Nah, next one. What's the name again? Kalia, help me out here, not here. Yeah. Help me out here. Sorry, writing back 3x plus 2. 4 plus 1. 3. Very good. That's it, right? So you can leave it like that, or you can write it like this. 1 over 15 by 3x plus 2 to the 5. Okay? That's okay? Yeah. Right. Before making harder, head up. That's okay. So just put a little note underneath. Note that all of these integrals are called indefinite integrals. Oh yeah, I forgot to show you something in differentiation. Right? It's called limits. I'll show you that. Right? But what I'll do is a video. So you'll always have to look back and a short thing. Right? I need to introduce something called limits. It came one year. First principles, like you know about that. I'm gonna show you that. I forgot to show that. All right. So all of these integrals here are called indefinite integrals. So I want to show you something called definite integrals.
Yeah. I also, I can pray.
Everybody ready? All right. So here's what we're going to deal with now, right? If you go to the calculator somewhere in the top right hand corner, you will see an integral symbol. Right? That allows you to work this out. Okay? So I want to show you how to use the calculator to do definite integrals as well, right? So if we have the integral of b on a of f of x, here what you do, right? Here what you do, right? What you do is just integrate f of x, and the way you write it is write capital F. The integral of lowercase is capital, uppercase, right? So what you do is just integrate this, and then drop in the b, work it out, and then drop in the a, work it out. And the answer is your integral. All right, so what does all that mean? All that simply means is this. Watch a small example here. If I have 4 and 2, and I want you to integrate this, here what you do first. The first thing you do is integrate it. So you will get 3x cubed on 3 minus 4x squared on 2. There is no need to write plus c anymore. And I'll add y just now, right? And then after you integrate, no longer you write this symbol, you write a straight line, and you put 4 and 2. So what you're going to do with that 4 and 2 now is drop it in here. Let's simplify this first. This is x cubed minus 2x squared. Ready, done? What are you going to do now? Pay attention now, boy. Plug in the 4 now. So I'm going to drop in 4 because this is the integral of this. So I'm going to drop in 4 here. 4 cubed minus 2 by 4 squared. And now I'm going to minus, dropping in 2 in here. 2 cubed minus 2 by 2 squared. Okay? So I'm going to put 4 in here, work out that value. Put 2 in here, work out that value. And then subtract them. That's okay? Help me out now. The calculator. Still in, pay attention, right? Take it a minute. Huh? What's that? 64 minus 32, right? That's 32. And here is what? 8 minus 8. So yeah, still 32. Check it and make sure. 32? Yeah? No? Right. Here's what you're doing for me now. Go to the calculator. Put this in the calculator for me. Look for the integral symbol and look for the x. The straight line means that you've finished integrated. So you do this. Go to the calculator, put in integral, put in everything exactly what you see in here. Right? Left hand corner or something like that.
Should be here.
Your guy itu. Right, so investment cash you, right? You'll need it.
Is that game play? That's why.
Alright, let's go again. Right, you. She's talking, but he don't have a note. Try this, please. Try this one here, please. Do it both ways, right? In the calculator and work it out in full, right? But not one alone. Both of them. Oh yeah, try that yet. Let's see what you got.
Right, we talk in my on the only. Hey. I show some of the five standards.
Alright, Chris, how you up now? Work out the value.
Yes, you don't figure out. So how much watch? But usually we use both.
Any answers? Any answers? That's what I have now. That's not working. Come on, where you guys? Final answer. Okay. Online, any answers? 1 over. Sure. Online, any answers? Send your final value, right? Still in earlier. And I just send your final value. Everybody online. I will hope I reach.
But I think we think good.
We should take it out.
So, I'm with Tony Practice on a good one.
Huh? So are you done? No, she get funded out. How much? Oh, well, big value. Yeah, well, I'll make it up. I'll make it up. That's the power 6 something, right? That's possible. Right, so when we start to integrate, what you got? Add 1 to the power, which is 6, divide by the new power, and divide by the differential of 2x plus 1, which is 2. Now, all I have to do is plug in 2 here. So that will be 2 by 2 plus 1 to the power 6 all over 12 minus 2 by 1 plus 1 to the power 6 all over 12. This will be extremely large because it's 5 to the power 6, right? How much you got? 15,625. Okay, let's go again. You'll grab the calculator as well when you plug it in. Right, try one slightly harder. Tell me what you got.
What is mine?
How much is here then? 7. So the final answer is all is divided by 12. One. 1 to what? 1 2 4 1. Right? What you'll do here? What you'll do here before I integrate it? Bring up the x, okay? Or you just divide x cubed by x, x squared by x. Right? So you have to simplify it first, right? So it's 3 minus 1, 2 minus 1, then you integrate. Try this fast. So So simplify first. Everybody got that? 1.3. Hurry up. Number 3. Bishish. You have to divide them. But you have to simplify first, Bishish, before you integrate. Huh? Simplify. I divide everything by everything. How about black or blue? That's me. Oh, Nurisan also answered very good. Alyssa, very good. All right, let's go. Ready? Ready? Right, first step. First step before we integrate. So watch, earlier, because I didn't integrate as yet, I'm still leaving the integral symbol, right? And now I'm going to simplify that. X cubed divided by x is 4x squared divided by x is 4x. Okay? Please don't just divide these two alone. You have to divide x cubed by x and 4x squared by x. Now we can start to integrate, right? So when you integrate, you'll get x cubed on 3 minus 4x squared on 2. Okay? When you're done plugging in 2, you'll get 2 cubed on 3. This will cancel. You'll get 2 by 2 squared minus 0. Right? If you put 0 in here, you'll get 0. So we'll get 8 over 3 minus 8. Right? I got minus 16 on 3. Yeah? Okay? One more, integral of 3. Yeah, don't give him more, that's not, but integral of 3.
You should see red.
Yo. I don't think you realize I'm starting messing up. Yeah. Vision, they can't see that. You're wrong.
All right, let's go. All right, ready? Let's go. Let's start. No, pull up that. Right, integral of trigs. How do we integrate trigs? Just reverse the differentiation, right? What's the integral of sine? Minus cos x. Check it back and see. The differential of cos is minus sine. Minus and a minus will give you a plus. What's the integral of cos? That's all. Watch here. How do we integrate something like this? Real simple, right? All you have to do is 1 over, you have to remember this rule, right? 1 over the differential of ax plus b, which is, what's the integral of sine? Minus cos, then you write back ax plus b. Watch it again. Watch it again. Watch it first, right? Akira, watch it first. 1 over the differential of ax plus b, which is by the integral of sine, which is, right? And then you write back ax plus b. That's okay? Same thing here. 1 over the differential of ax plus b, which is by the integral of cos, which is, then you write back ax plus b. That's okay? Copy it down. I want to give you the 4 steps because I know you'll forget it.
So we talking.
Nah.
What
time? Well, time is sex for you. Y'all didn't learn time. Y'all didn't learn time.
That's a great question. We don't like that.
No, the integral of the cup.
Is it more for play?
Hurry up now, right? Write these 3 steps down to help you remember. These steps are used to integrate trigs, right? Step number 1. Are you ready? No? So you know we're focusing on next next week we're missing class. We doing too far. Next week is the one.
Yeah.
So what we do week after we could double them. How people like again. Huh? Sorry. Next Wednesday we will miss next Wednesday too. Not so important, no, not so important. That's one more important between 2 of them. Sorry. Because I mean, have to know.
I don't think so.
Alright, ready? Take a small note. Step 1. Step 1. 1 over the differential bracket. Step 1. 1 over the differential of the bracket. Right? You can write it in words or you can write it like this. Right? Step 1. 1 over the differential of the bracket. Whatever you have in here. That's step 1. Step 2. Integrate the trig. Step 3. Write back the bracket. Okay, that's it. That's the way you integrate trigs. So I'm gonna give you 2 to do here from now. Online, the second one, I want you to send my value, right? Still then you included. You didn't send me anything the first time. All right, let's do number 1 together. Let's do number 1 together with no. Jalen, help me out here. What's the integral of sine 2x? Take your time, follow the 3 steps. Minus, it jump a step. 1 over what? 1 over the differential of? What's the differential of 2x? 2. So it's 1 over 2 by the integral of sine, which is minus. And the last step is what? Write back the bracket. Here's 2x. That's okay? Right, before you do this, we have 2 problems. Chris, what can I do with this for? What can I do with this for? Okay, or I can put it for outside. Right? In integration, you can pull the 4 on the outside. You don't have to worry about too much. Right? And then you go and integrate this. But we have a slight problem here. We have pi over 2 and 0. What does that mean? We have to work in radians. Okay? So I want you now to try this question, but I want you to remember to work in radians. Take your time, try this please. So make sure calculators convert it to radians, right? Copy it down. Yes. We're almost done. This is the last new thing. No, nothing else new in integration, right? We're working in radials and don't forget it 4 on the outside. Work it out with and then come back to 4. Don't forget it 4, right? 4. After you work on it, go take it out.
So a big guy. That's it. That's it. Yeah, because you don't see the happens.
Right, let's go. Help me out here, Soraya. I'm leaving the 4 on the outside, right? What's the integral of cos 3x? Soraya, you will that?
Why?
1 over
Oh,
1 over not. 1 over what? 1 over 3 sine 3x. Right? What's the next step, Vishish? What's the next step after you do this? Substitute pi on 2. So 3 by pi on 2 minus 1/3. Right? If you want earlier, you don't have to write the 1/3, you can put it outside here. Okay? You don't have to write it here. Any constants in front of this sign, you can factor it out. What's the final answer? This is 0, right? So I got minus 4 and 3 is the answer. Yeah? Check and see. This is 0 for sure. This is 3.5, so that's 1, 2. No, that's positive 4 and 3. Minus 4 and 3. All right, 3 and 2 is 1.5 pi, so that's here. Again, check and see. Quick in the calculator. I got the next answer online. Nice. Huh? Yeah, minus 4 and 3. 1 plus 4, 2. What? Oh, wait.
Let's take this.
Ready? One more. Last one, right? Kita paling yang udah sudah put that is back. Ada dua kelas nanti.
Well, you have to prove it.
I got them for
We need that.
Alright, try that. No way. I just don't want to forget this when we start the application. I mean, 1 week is unquestionable. 2 weeks to remember this. Right, what you're going to do in a case like this? What you're going to do if I give you sin x and cos x? Right, so you integrate this and this separately, right, and work it out. Okay, integrate sin, write down your answer, integrate cos. Hurry up. Last one. Come on, let's finish the fast one I'm watching. Online, I would like an answer from everyone. Chelsea and Arissa, Anaya, who is this one? Eiffel answers. There so you send me one. Sterling and Sydney. Sydney said I'm quiet, they understand anything. Come on, Sydney. Last one I'll be done all.
Oh, no.
One person, people talk for one person. So yeah, got my finish. Radian. Once you see pi is radians. In integration, we don't use degrees, right? So make sure I calculate the radian. Yeah, book it out in full. Yeah, do the minus signs. Hello. Previews in chat, and I'll give a training system. Right. I'll do a lot of what you Satellite do it in December or do it close in December? Something one side down. I do a lot of cash for
Okay, now one.
So far, I'm just waiting. So, you know, you notice? Okay, next one. You are still knowledge trade. No, but you said no plus zero. You said no sign. Somebody take it as well. Guys, hurry up.
Right, and yes, thunder. Same question lang sila nito. Same question lang sila. Yeah, it was also. Huh? Yeah. You know what? You this.
Right online, send some values. Send some values there. Still it said 2, correct? And I said 2. Good. Any more from online? So the answer is 2. Right, so all we have to do is this. Pi and 0 minus cos x plus sin x. Plug in pi. And then plug in 0. Right, this value is 1. That's 2. Okay. So next day we're going to do the applications of integration. We have 3 things to look at. Okay. What are the 3 applications of integration, Kishish? What are the 3 applications of integration? Data at the beginning of the class. The volume, the area, and the reverse, right? All right.